Hello, Longhorns. This is Ms. Clay. Today we'll be discussing or starting a new unit, and we'll be discussing Pythagorean theorem. Okay, so let's first refresh some of our thoughts about right triangles. Okay, so a triangle that has one right angle is considered a right angle. It has to have a 90-degree angle. It's usually shown by this box right here, right? Oops, let's get our pen working here. There we go. Okay. So it's usually shown by this box right here, and that represents 90 degrees, right? The other parts of our triangle, we have two legs, right? Leg right here and a leg right there. If you remember when we talked about that in the fall, you can remember that because they look like the sides of an L. So those are our two legs. Then across from our leg is across from our right angle is our hypotenuse. It's also the longest side of your triangle. So as we go back to our properties for our triangle, so we know that our box represents 90 degrees. And so we have to have a 90 degree to be right angles. 90 degrees equal right angle, right triangle. And I'm just going to use the triangle symbol right there. Okay, so then the other things that we need to know, let's label these two other angles. What do we know about these two other angles on a right triangle? Okay, so all angles in a triangle equal up to 180 degrees, right? So if we said the measure of angle A plus the measure of angle B plus 90 is equal to 180, right? Everybody remember that? So let's move our 90 over here to the other side. And so now we're left with measure of angle A plus measure of angle B is equal to 90 degrees. So we know these two angles have to equal up to 90 degrees. Do you all remember what that's called? See, complementary, right? So complementary angles add up to 90 degrees. Up to 90 degrees, okay? So that kind of refreshes us. I'm back on the thing. So let's go into Pythagorean. So Pythagorean's theorem was named after a Greek mathematician named Pythagoras. He discusses the relationship between the two legs and the hypotenuse. So remember, this is our leg. It's on the side of our right angle. This is our other leg. And then our hypotenuse is across from the right angle, and it's also our longest side. Okay? He developed a formula. So we're going to name this side A, this side B, and this side C. The formula states that A squared plus B squared is equal to C squared. So let's plug in some values for our letters. So let's do A is equal to 3. Let's put B over here. It's equal to 4. And we're going to put C is equal to 5. So let's plug this in. Okay, so we have 3 squared plus 4 squared is equal to 5 squared. All right, so we got 9 plus 16, and we got 25. Well, 9 plus 16 is 25. So indeed, they are equal. Okay, so check that off. Yay. Okay, so that's what the theorem states. So here's it written, so you have it for your notes. The theorem states if a triangle is a right triangle, then the sum of the squares of the lengths of the legs is equal to the squares of the length of the hypotenuse. So here we go. A, B, here's our hypotenuse C. So A squared plus B squared is equal to C squared. Okay, the two legs equal the hypotenuse. All right, so let's add on and find what's the length of the hypotenuse of triangle A, B, C. Okay, so let's call this one A, this one B, and of course, this is C, right? So let's write our formula. A squared b squared is equal to c squared. So a squared is 18 plus 24 squared plus c squared, because we need to determine that one, right? So that is 324 plus 576 is equal to c squared. So this is equal to 900. It's equal to c squared. So now we take the square root of both sides because we need to get c by itself. So we end up, you can put it in your calculator. You end up with c is equal to 30. All right? Now, the next concept we're going to talk to and add on to is the Pythagorean triple. It's a set of non-zero whole numbers, a, b, and c, that satisfy the equation a squared plus b squared is c squared. So for example, let's go back. This example right here is an example of a triple because all three numbers are whole numbers. Remember, for a triple, it must be a non-zero whole number. So some very common triples are 3, 4, and 5. Well, that's one of the examples we did in the beginning. 5, 12, and 13, 8, 15, and 17, 7, 24, and 25. Okay, so those give you some popular ones. So next, let's do this one. The legs of a right triangle have the lengths 10 and 24. Okay, so let's go on and draw a triangle real quick. There we go. All right. Now we'll go back and then I'll fill in our other items. Okay, so I'll draw our box here to represent this is a right angle. Okay, so the two lengths they give us are 10, this is one of our legs, and 24. So I'm going to call this A and this B, and we need to find C. Okay, the length of our hypotenuse. So a squared plus b squared is equal to c squared. So 10 squared plus 24 squared is equal to c squared. So 100 plus 56 is equal to c squared. Add those together, we get 676 c squared. Now let's take the square root of both of them. So we get c by itself. And so c is equal to 26. Okay, and I'm going to box that so y'all can find it easy. Okay, so now we know this hypotenuse is equal to, to 26. Let's scratch that out. Let's write it again. Okay. Now, the other thing that you'll have to know how to solve is if they give you a leg in the hypotenuse. So it's still the same formula. So let's do this. A, B, and C. All right. So we need to find x, which is one of the legs. We've been solving for the hypotenuse the other times. So let's do a squared plus b squared is equal to c squared. So we have 45 squared plus x squared, right? Plus 51 squared. Okay. So now you can put those in your calculator. Okay, excuse me, I had to get my calculator. Okay, 45 squared is 2025 plus b squared, or really, we'll just keep it as x squared, is equal to 2,601. All right, so now we need to get x squared by itself, or in our case, if it makes it easier for us to think about it, we'll put b squared by itself. Okay, so let's subtract, since that's how we, to the other side. Okay, so now we're left with b squared is equal to 576 So now we take the square root of both sides. And so B is equal to 24. Okay? So if they ask you A or B, one of the legs, then that's how you go about solving it. Okay? And just subtract. Okay, let's do some examples of our triples real quick. So does each set of numbers form a Pythagorean triple? So remember, a triple means the numbers end out to be a whole number. Okay? So let's do, remember our formula. Let me write it up here so we have it. Make sure we all remember it. Okay, so we have 6 squared plus 8 squared. We take the two smallest sides, or two smallest intervals, right? The hypotenuse is always the longest. So we got 36 plus 64. So this is equal to 100. And what is this equal to? This is also equal to 100. So those two are a triple. There we go. Let's try this next one. 7 squared plus 16 squared, 18 squared. Okay, so we got 49 plus 256. When you add those two together, we get 304. And 18 squared is 324. So those are not equal, so they do not form a triple. Okay? Our last one. Let's do a real world example. You know how I like to do that. And I love baseball. So on the baseball field, the first and second base are 90 feet apart. The catcher is located at home plate. He wants to throw out a runner stealing second base. How far is the throw? So let's think about what we know so far and label it. So we know the distance between first. Let's go on and label our bases in case anyone needs to know. That's first, second, third, and this is home right here. This is home plate. This is where our catcher is, okay? So the distance between first and second is 90 feet. So we're gonna say that side is 90 feet. Well, if you notice, the infield of a baseball field forms a square. So that means all the sides are congruent to each other. We'll show that by doing our little tick, okay? The other thing, now we need to notice where the catcher is. He's at home plate and he wants to throw it to second base, which is right across the line. And sometimes I don't draw lines the straightest. So let me see if I can get my little guy to make a line for me. There we go. There we go. Okay, that looks better. Okay, so the catcher wants to throw the ball from home plate to second base. So if we notice, now all of a sudden this splits the square in half. And what do we have? We have two triangles, but more importantly, what type of triangles? We have two right triangles. Okay, so now we know that we can use the Pythagorean's theorem to figure out the hypotenuse, because we already know this side is 90, right? And this one is 90, so we just need to know this. So let's set up our formula. A squared plus B squared is equal to C squared. So we have 90 squared plus 90 squared. Whoopsie, not a degree. Is equal to C squared. So 8100 plus 8100 is equal to C squared. So add those two together, you get 16,200 is equal to C squared. And if we take the square root of that for both sides, we wound up getting C. I'm going to write it over here because I'm running out of space. C is equal to 127.29 feet. So that's how far he throws the ball. Okay? All right, that's all for today. Have a great one.